Leetcode 53 maximal subarray. What they actually are asking for is find the subarray that has the maximal sum. So obviously it's not the maximal subarray. The maximal subarray is the whole array. Find the subarray that has the maximal sums. So for this example, they found that this subarray has the maximal sum of 6, and notice that it's contiguous, meaning you cannot choose a number from here, a number from here, a number from here. Okay, so let's go directly to the answer. Right, so because they didn't ask to choose items, but they are contiguous, then we can possibly get away with the left and the right pointer. If they asked to choose, and it would not be subsequence, any numbers that would provide the maximal sum, then first we could choose only the positive numbers, but let's say that we could just choose numbers. Then this would hint that we need a recursion, because each time we would need to say, okay, solve the sub problem while choosing this item, solve the sub problem while not choosing this item. But because they didn't ask for it, and all they asked for is to find the subarray, contiguous subarray with left and right boundaries with maximal sum, then we can get away with left and right. Okay, so let's look at this. We initialize left and right to 0. We initialize the current sum to 0. We initialize the current answer to float of -infinity, because we are going to use the max function. So this would help us always. That answer would if we increase it, if we set answer to 0, then if the maximal sum is negative, we would never get it with the max. So we initialize answer to -infinity. Some trick in Python. Okay, so now because we are having a left and the right pointer, we follow the pattern. The external loop is for right in range length of nums. The external loop will simply always increase the right. Each time we get into the loop, increase the right, increase the right, increase the right, increase the right. So just a loop on increasing the right pointer. Every time we increase the right pointer, add the current number that the right is pointing to, the new current number, to the current sum. So cur is nums right, plus equal num right. Now, because we added a new number, let's check if this new current sum is bigger than the answer with the max. If it's bigger than the answer, then the update answer to be the max of answer and current. That's it, we increase the right. But what if the current sum is negative? Then it would not really help us, right? When we increase to the next right. Okay, let's even say that the next right is -1. If here we have any negative number on the current sum, it won't help this number. It would only reduce it from -1 to -2 or to -3. So we want to get rid of the current sum. So this is the condition of when to move the left to the right. The condition of when to move the left to the right is as long as it's negative. As long as it's negative, it only reduce the current sum that we have. So so we had the external loop for right in range length nums. Then for each external loop, we updated the curve, we added the current number on the right, then we updated immediately the answer to be the maximum of the answer and the current number to the right. And now we say that if the current sum is negative and left is still on the boundaries, left is less or equal than right, then the current sum, remove from it the left and increase the left. This is the condition to increase the left. So basically what we say is that we have a left and the right pointer. We increase on each external loop iteration the right pointer. We update the current sum. We update the answer to be the max of the answer of the current sum. And now we need to decide on the left pointer. If the current sum is less than 0, it's negative. Increase the left pointer, and of course, as long as left is less or equal than right. Of course, when we increase the left pointer, we remove the current left number from the current sum, and that's it. That's it for this problem, and later on we return the answer. This was Leetcode 53. Find the maximal sum of the subarray, where we used a standard right loop on the right pointer, an if condition on the left pointer. When the current sum is negative, just increase the left pointer, remove the number from the current and for each iteration of the right pointer, it's proceeding. It has to go from 0 to the end, right? It has to scan all the numbers. So for each proceeding, for each iteration of this external right loop scanning, we update the current sum and we check if the answer can be updated. Right, so this was Leetcode 53 maximum subarray.